Dear students, Vetri welcomes you all. I am Dr. Gunasekaran, Professor of Chemistry. Today I am going to discuss under the volumetric analysis the titration of potassium permanganate versus oxalic acid. This is coming under permanganometric titrations. First, let me discuss aim. Let me discuss aim. Estimate the strength of potassium permanganate and the amount of substance present in 1 liter. That is the aim of the experiment. That means you are provided with 250 ml of unknown potassium permanganate solution. Unknown potassium permanganate solution. And a bottle containing crystalline oxalic acid and necessary apparatus will be provided. That means burette, pipette, beaker, and the burette stand. All apparatus is necessary for this. Now, what is the basic principle involved in these titrations? Potassium permanganate is a powerful oxidizing agent, whereas oxalic acid is a reducing agent. Potassium permanganate is a powerful oxidizing agent, whereas the oxalic acid is a reducing agent. In dilute sulfuric acid medium, both undergo redox reaction as follows. That is, 2 moles of potassium permanganate reacts with 3 moles of sulfuric acid, undergo redox reactions with 5 moles of oxalic acid, crystalline oxalic acid. To form potassium sulfate, manganese sulfate, and 10 moles of carbon dioxide, 8 moles of water. So here, no external indicator is required. Potassium permanganate itself acting as an internal indicator. Potassium permanganate is acting as internal indicator. Kindly follow. Now we'll come for the experimental part. So there are 2 experimental parts. One is we have to prepare a standard solution of crystalline oxalic acid. Number 2, we have to estimate the strength and amount of potassium permanganate unknown solution. First, let me discuss preparation of standard solution of crystalline oxalic acid. Crystalline oxalic acid. About 1.6 grams of crystalline oxalic acid is weighed accurately in 50 ml beaker and transferred quantitatively into 250 ml standard flask. After dissolving in distilled water, and it is then transferred quantitatively and made up to the mark given in the 250 ml standard measuring flask using funnel. After closing with a suitable glass stopper, standard measuring flask, SMF, standard measuring flask, is shaken carefully for uniform concentration. For uniform concentration. Next, 20 ml of oxalic acid solution, that is what we have prepared by weighing, oxalic acid solution, we will call it as standard solution, is pipetted out into a 250 ml capacity of conical flask. 20 ml of dilute sulfuric acid is added into the conical flask using 50 ml capacity of measuring jar. Because dilute sulfuric acid we have to use measuring jar. The condense the flask, that is, it is then heated to 50 to 60 degree, bearable warm, until a bubble comes. The contents of the flask is then titrated against potassium permanganate solution taken in a 50 ml volume of burette in the burette stand. Now, titration is conducted slowly and then fastly, because beginning we have to conduct slowly because the reducing agent oxalic acid is a very, very weak acid, so reaction will be very slow. So titration is conducted slowly first, dropwise, and then fastly. Here, appearance of pink color is the end point. By addition of 1 drop of potassium permanganate solution. So when we are titrating, and if we lost 1 drop, if we are getting a pink color, stop the additions. Note the volume of the solution in the burette. Please follow. So, here the correct volume is noted as 22 ml from the burette. So, in this experiment, I have noted 22 ml from the burette. So, titrations are repeated for concordant values. So, we have to repeat for 2 times or 3 times until the same values are obtained. So, coming for the calculation, in the titration of potassium permanganate versus oxalic acids, now see the reaction, that is stoichiometric reactions. 2 moles of potassium permanganate reacts with 3 moles of sulfuric acid plus 5 moles of crystalline oxalic acid to produce 1 mole of potassium sulfate, 2 moles of manganese sulfate, and 10 moles of carbon dioxide, 8 moles of water. Now, according to volumetric formula, we know V1M1 divided by N1 for crystalline oxalic acid, that is equal to V2M2 by N2, that is for potassium permanganate. Here from the stoichiometry I can identify the mole. This is for oxalic acid. This is for potassium permanganate. Kindly follow. So, from the stoichiometry, I've identified 2 moles of potassium permanganate, so 2, oxalic acid 5 mole. Now, we know this is the standard solution for the crystalline oxalic acid, volume 20 ml, volume 20 ml, kindly follow, and M1 from the calculation 0.05 M, and coming for the potassium permanganate, volume we have noted 22 ml. So we have to estimate the strength of, that is molarity of potassium permanganate M2. We have to calculate. So I am now substituting here, just see here, 20 ml of crystalline oxalic acid, molarity 0.05 divided by 5 moles, that is equal to M2, that is the molarity of potassium permanganate, volume I have noted from the burette, that is 22 ml. So the mole is 2. So by doing calculation of this one, so we have to calculate M2. Please follow. And before that, I want to give some information. I have weighed crystalline oxalic acid 1.6 gram. Volume of crystalline oxalic acid prepared is 250 ml. So by doing calculations, molarity, that is equal to, that is, we can give mole, that is mole by volume. Kindly follow. That is the formula. Number of moles of solute, you can say N2 by V, volume of solution. That is, what is N2? I can say M2 into capital M2, capital M2 divided by V. This is the actual formula. So from this we can calculate the molarity is 0.05 M. Okay, right. So now according to the volumetric formula we have already seen already. Now I will go for the calculation. In the calculation I have already written this. Kindly follow. 20 in 0.05 by 5, that is equal to M2 into 22 by 2. So from this I want to calculate the molarity of oxalic acid. M2 is equal to, so I am doing this all calculation. I am getting the final value is 0.018 molarity, mole. Kindly follow. This is the molarity of potassium permanganate. So if you want to calculate the amount of potassium permanganate present in 1 liter, strength into molar mass. Strength I have already calculated 0.018 M. Molar mass 158. So on multiplication I am getting the value 2.844 gram per liter. This is the correct answer for amount of potassium permanganate present in 1 liter. Okay, thank you. The next volumetric titrations I am going to do, that is oxalic acid versus potassium permanganate. This is comes under the permanometric titrations. Here again, there is no indicator required. The permanganate itself is acting as an internal indicator. As usual, what I have to do now, I have to weigh accurately, I have to prepare solution of 0.01 crystalline oxalic acid. The molecular weight is 126 crystalline oxalic acid. So if I do calculation for 250 ml, if I want to prepare, I will make it into 250 ml glass, I will make it into solution. Then as usual in the case of ferrous ammonium sulfate, I will do titration. The only difference is, in the case of ferrous ammonium sulfate, I am not necessary to heat. Whereas, in the case of oxalic acid, I have to heat the solution up to bearable warmth, 60 to 80 degrees, because the reaction is very, very slow. It's a weak oxidizing agent, reducing agent, so that the reaction will be very slow. Okay? So let me weigh and prepare the solution. Oxalic acid, crystalline oxalic acid, molecular weight 126. To prepare 1 mole of solution in 1 liter, I have to dissolve 126 gram. So I need only 0.05 in 250 ml. So I have to weigh. So from this, using the weighing balance, the weighing the analytical machine, I am going to weigh with the help of a beaker. So I am taking the beaker and make it 0. So now I am going to add. Please wait. So here I have taken 1.60 with the beaker. I have taken oxalic acid. Then this I have to make a solution in this the 250 ml standard flask using water and the sulfuric acid medium. Kindly follow. So let me start now. Please wait. So I am now preparing the oxalic acid solution with the help of funnel. I am tampering the substance and I have to prepare up to the mark given in the flask. Kindly follow. When it is nearing the mark, I have to remove the conical, that is our the funnel, we have to remove. So better, I am now removing the funnel. So I should be carefully fill up. So I will show you after filling up. Kindly follow. When it is nearing the level, I have to use pipette. I have to use pipette on the corresponding water bottle. I have to add in dropwise. I have to add in dropwise. I have to add. Just see that I am adding dropwise to the mark. One drop I have. Actually, we have to use pipette the correspondingly. Okay. Now listen. Just see that it is a mark above, that is below the mark is there. So now I have to close this solution, that is oxalic acid. I have a shake valve to prepare standard solution. The standard solution is, I have taken 1.6 gram in 250 ml. Approximately the scent will be 0.05 molar solution. So with this solution, I am going to titrate against potassium permanganate as in the case of ferrous ammonium sulfate. Okay? Right. Let me start now. The 20 ml of oxalic acid from the solution I have prepared. Since I have inserted into the bottle, the outer I am just see here the wetness I am removing with the filter paper because it may affect the value. And just see at the top level, I should adjust to the mark. I have to adjust to the mark. So with the help of a gas beaker, I am adjusting the mark to the level. Then only it will be exactly 20 ml. It will be exactly 20 ml. Yes. Now, just see if the level is exactly 20 ml. So, I am transferring into this oxalic acid solution. Can you follow? That is containing the acid medium, sulfuric acid medium. The only difference I have already informed you, you touch at the top 2 times. I have to heat. So 60 to 80 degree in wherever you want. Just see here, I am going to heat now. I am going to heat the flask. Kindly follow. I am going to heat the flask. Kindly follow. You can see that I am heating this oxalic acid solution containing this one. Kindly follow. In the case of ferrous ammonium sulfate, I need not heat. Whereas in this case, in the case of oxalic acid, I have to heat because it is a weak reducing agent So it's an acid. So just it comes one bubble. You can take it out and shake now. So it is started bubbling now. Now I am going to the titrate. Kindly follow. I am going to titrate. Kindly follow. Just see here, I am keeping here, you are going to see that initially I should not add firstly as in the case of paracetamol sulfate, just a few drops. Then I have to shake, few drops. Then I have to shake, few drops. I have to shake, few drops. So slowly, initial reaction will be very slow, but if it is going for a long time, it will be faster. That is a very, very important difference between paracetamol sulfate and oxalic. Just see. Now I should not see the reading in the period. I have to see only the clinical class. So upon disappearance of blue color, that is pink color, I am seeing. When it is So, in the case of oxalic acid, now we have identified the end point. Kindly follow. This is after heating in the wire gas, bearable warmth 60 to 80 degree, I am getting the end point. Now the volume of potassium permanganate, as in the previous case, is again now, it is again 22. Kindly see here, it is again 22. That means both cases, the volume of potassium permanganate is same, indicating clearly that is both paracetamol sulfate and oxalic acid are 0.05. Okay. Now, I want to give one information. What you should not do in the laboratory during titration, I will show you now. Please wait. Listen me, in the case of oxalic acid, only after heating you have to do. Without heating, if you add, fastly what will happen, that you can see here. You can see here. So, this is oxalic acid. Without proper heating, I am adding fastly. Immediately, just see, few drops it's getting color. Within few drops I am getting color. So it is misleading you. Slowly then the color will disappear. So the mistake is you have to heat minimum 15 minutes until the bubble comes from the solution. Okay? This is the precaution. Thank you. Coming for the calculation, in the titration of potassium permanganate versus oxalic acids, now see the reaction, that is stoichiometric reactions. 2 moles of potassium permanganate reacts with 3 moles of sulfuric acid plus 5 moles of crystalline oxalic acid to produce 1 mole of potassium sulfate, 2 moles of manganese sulfate and 10 moles of carbon dioxide, 8 moles of water. Now, according to volumetric formula, we know V1M1 divided by N1 for crystalline oxalic acid, that is equal to V2M2 by N2, that is for potassium permanganate. Here from the stoichiometry, I can identify the mole. This is for oxalic acid. This is for potassium permanganate. Kindly follow. So, from the stoichiometry, I've identified 2 moles of potassium permanganate, so 2, oxalic acid 5 mole. Now, we know this is the standard solution for the crystalline oxalic acid, volume 20 ml, volume 20 ml, kindly follow, and M1 from the calculation 0.05 M, and coming for the potassium permanganate, volume we have noted 22 ml. So we have to estimate the strength of, that is molarity of potassium permanganate M2. We have to calculate. So I am now substituting here, just see here, 20 ml of crystalline oxalic acid, molarity 0.05 divided by 5 moles, that is equal to M2, that is the molarity of potassium permanganate, volume I have noted from the burette, that is 22 ml. So the mole is 2. So by doing calculation of this one, so we have to calculate M2. Please follow. And before that, I want to give some information. I have weighed crystalline oxalic acid 1.6 gram. Volume of crystalline oxalic acid prepared is 250 ml. So by doing calculations, molarity, that is equal to, that is, we can give mole, that is mole by volume. Kindly follow. That is the formula. Number of moles of solute, you can say N2 by V, volume of solution. That is, what is N2? I can say M2 into capital M2, capital M2 divided by V. This is the actual formula. So from this we can calculate the molarity is 0.05 M. Okay, right. So now according to the volumetric formula we have already seen already. Now I will go for the calculation. In the calculation I have already written this. Kindly follow. 20 in 0.05 by 5, that is equal to M2 into 22 by 2. So from this I want to calculate the molarity of oxalic acid. M2 is equal to, so I am doing this all calculation. I am getting the final value is 0.018 molarity, mole. Kindly follow. This is the molarity of potassium permanganate. So if you want to calculate the amount of potassium permanganate present in 1 liter, strength into molar mass. Strength I have already calculated 0.018 M, molar mass 158. So on multiplication I am getting the value 2.844 gram per liter. This is the correct answer for amount of potassium permanganate present in 1 liter. Okay, thank you.